Okay students, so welcome back to the next part of this online lecture. So let us just quickly recap what we did in the last online lecture. We already started with module number 4, that is sequential circuit, and we defined the meaning of sequential circuit. Essentially it's a combinational circuit with addition of memory element to it. Okay, and the basic building block of the sequential circuit we studied last time, and this basic building block of the sequential circuit we used to call it as a flip-flop, right? And if you recall, last time we saw 4 different types of flip-flops. Basically set and reset flip-flop, we used to call it as a SR flip-flop, then JK flip-flop, then third is the data flip-flop or D flip-flop, and the fourth one was the toggle flip-flop. Okay, so let us continue our discussion ahead, and today in a short discussion let us see how to convert one type of a flip-flop into another type. Okay, you may ask a question that why it is required to convert one flip-flop into another type of flip-flop. This is because in certain design problems it may happen that a particular type of flip-flop may not be available for use, right? Therefore flip-flop need to be converted from one type to another type, right? So suppose in some particular application you require a D flip-flop, but you are available with SR flip-flop, then you should effectively convert the SR flip-flop into D flip-flop. So that's why conversion of flip-flop from one form to another form is very important. Okay, so let us continue our notes. So let me write here today's agenda, the flip-flop conversion. So I will start writing from here, flip-flop conversion. We already know 4 different types of flip-flop: set reset flip-flop, JK flip-flop, D flip-flop and T flip-flop, right? So first of all, let us see the conversion technique, how we can convert the SR flip-flop into D flip-flop. Okay, so first conversion of SR flip-flop into D flip-flop. In short, how we can write this as, we want to convert SR flip-flop to D flip-flop. So how to do this, let us see in this lecture. So let me highlight this particular part. Okay, so first conversion, what we want is, we want to convert the SR flip-flop into D flip-flop. Okay, for that we need to write some conversion logic. Okay, so this conversion logic, when it is applied to SR flip-flop, the SR flip-flop will get converted into D flip-flop. Okay, so let us write that conversion logic. Okay, so how we can write the conversion logic? So first of all, we need to write the state, present state and next state of the desired flip-flop. Okay, so first of all we'll make a state table in this way. So in first column I will write present state. Okay, present state is indicated with letter Q, right? Then the next state of the flip-flop. So this is the present state, and next state we are talking with respect to converted flip-flop. So first of all you convert the given SR flip-flop into D flip-flop, and then we are talking about the present state and next states of this converted flip-flop, right? So next state, how we write? Next state we indicate with Q plus, Q to the suffix plus. Okay, then the flip-flop to which we want to convert, these inputs are written over here. Now the flip-flop to which we want to convert is a D flip-flop. Okay, D flip-flop. Now input, D flip-flop input. Now we know that D flip-flop has only one input, that is a data input, right? So what we do, along with the D input, we will take a present state of the flip-flop also, that is Q. Okay, and then the flip-flop which we want to convert, that is a SR flip-flop, we will be writing its input in the last column. So here I will write SR flip-flop. So this is a standard procedure to convert the given flip-flop from one format to another format. So for SR flip-flop we know that there are two inputs, right? So these are S and R. Okay, so we are going to make a table like this. Okay, so then first of all what we do is we will write the 4 different combinations for the present state and the next state. Okay, so the present state could be 0 and the next state can also be 0. So this is the first condition. Okay, the second condition is the present state is 0 but the next state is 1. This could be another condition. The third state is the present state is 1 and the next state is 0. Actually this is a reset condition, right? And the fourth state, the present state could be 1 and the next state we want is also 1. So these are the 4 different steps. Okay, now what we do is whatever there we wrote in the present state here. So let me change this highlighting color. So this Q state we are going to copy as it is in the column of Q input of D flip flop here. Okay, so 0, this is a 0, right? Present state we are copying as it is here in the column of D flip flop input Q column, as it is we are copying. Okay, and now you just recall the truth table of SR flip flop. Okay, so SR flip flop, first of all you write the inputs of SR flip flop S and R by considering the present state and next state which are shown in the first 2 columns. When present state is 0, next state is also 0, then at that time S is 0 and R is don't care condition, right? Similarly in the second step, when present state is 0 and next state is 1, so this indicates S set condition. So for that S should be 1 and R should be 0. This we know. Similarly when present state is 1 and next state is 0, this is a reset condition, and for this we need to keep S is equal to 0 and R is equal to 1. Okay, and finally this fourth condition, when present state is 1, next state is also 1, so that means X is a don't care condition and R is a 0. So this we know from the truth table of SR flip flop. Okay, now what is important to write here is the column which is left with the D input here. The column which is left with the D input. Okay, the column which is left with the D input, let me highlight this with a yellow color, this input we want to write. Okay, so now you pay attention to the present state. The first 2 columns, present state is 0, next state we also wanted 0. So what will be the value of D? We know that whatever you give at the D input, the same input will be made at the next state output. So for that, in order to get the next state 0, we should give D is equal to what? Here 0, right? Now see the second condition, present state is 0, next state is 1. Okay, so when the next state is 1 means you need to give D is equal to 1, right? Similarly the third step, present state is 1, next state is 0, then what input you need to give at the D input? That is 0, right? Present state is 1, next state is also 1. So for that you need to give D is equal to 1. Okay, so this is how we constructed the table for converting one flip-flop into another flip-flop. Okay, now what we do is we will draw K-map for S in terms of D and Q. So here I will write designing K-map for S in terms of D and Q. How many inputs are there? D and Q are the input, and we want to write the equation of S in terms of D and Q. So it's a two variable, that means we require a K-map of two variable, that means 4 boxes. So let us do that. Okay. So we are writing K-map for S in terms of D and Q. So let us take D over here and Q over here. This is 0, this is 1, this is 0, this is 1. Okay. So we want to write in terms of S. So when S is going to become 1, so here for that particular condition, for this particular condition, when S is equal to 1, this S is equal to 1 is coming for when D is equal to 1, Q is equal to 0. D is equal to 1, Q is equal to 0 means here, right? And we also want to take the don't care condition of S. The don't care condition of X will exist when the D and Q inputs are both 1. D and Q both are 1. So this is X, right? So what we do, we can combine this to form a group, right? So what the equation for S, you will get S is equal to directly, so this 1 0 1 1, so what it will remove from this, so it will remain D and the Q will get cancelled. S is equal to D, right? S is equal to D. Okay. Now similarly what we do is we will draw the K-map for R input of the SR flip-flop. So here again or rather I will write here only designing K-map for R input, right? In terms of D and Q. Again a 2 by 2, right? 2 by 2 K-map. Okay. So this is a K-map for D and Q again, D and Q, right? And this we want to write for R input. Okay. So we will take the don't care condition also over here. Now don't care condition, R is equal to X. So that exists for when both D and Q are 0 and 0. This is 0, this is 1, this is 0 and this is 1. When both 0 0, so here what we should write here as X, right? And then when the R input will become 1 for which combination of D and Q? When D and Q becomes 0 and 1. 0 and 1, so that means over here. Okay. Rest of the things are 0, right? So it is likewise here. So what we do is we will combine these to form a group, right? So if we combine these, what we get, the R is equal to now the Q will get vanished, right? And Q will get vanished, and we will get this is equal to D bar only, D bar. Okay. So how we convert the SR flip-flop? So what happen is S will become D and R input of the SR flip-flop will become D dash or D bar, one at the same. Okay. So first of all we draw the SR flip-flop. So I will draw the SR flip-flop here. Okay, so let me take another one. Yes. Then the two inputs we know, SR flip-flop. This we want to convert into D flip-flop, right? So that we got the answer. So this is a flip-flop and there are two outputs, right? Q and Q dash, or you can call Q and Q bar with a clock input. This is a clock, right? Now what we want to connect at the S input, D, and what we want to connect at the R input, that is complement of it. So what we do is, so here we directly connect D as an input, right, and take its complement and connect it to R input, and this will convert the SR flip-flop into D flip-flop, right? So this is a simple procedure to convert the SR flip-flop into D flip-flop. Okay. So likewise, let us go ahead and convert one more flip-flop into T flip-flop. So let us say second conversion of SR flip-flop again. We want to convert SR flip-flop to T flip-flop or toggle flip-flop. Okay. So in short, we also call this as SR flip-flop to T flip-flop conversion, in short. Okay. The second conversion. So what we want to do is, we want to convert the SR flip-flop into toggle flip-flop. We already converted the SR flip-flop into D flip-flop. So likewise, now let us convert the given SR flip-flop into T flip-flop. Again, let us build the table. Again, we need to write the present state, next state, then the inputs for T flip-flop, and then the inputs for SR flip-flop. Okay, so let us write present state. How the present state of the flip-flop is indicated? It is indicated as Q. Next state of the flip-flop, how it is indicated? It is indicated with Q plus, right? Then in the third column, what we do is, we take the inputs for T flip-flop. T flip-flop input. Now we know that for the T flip-flop, we have only one input, that is a toggle input, T. What we do is, along with the T, we take the present state also of the flip-flop, Q. And then we write inputs for SR flip-flop. SR flip-flop input. And we know that there are two inputs for the SR flip-flop, that is S and R. Okay. Then first of all, we will write the four possible combinations of present state and next state as usual. Present state 0, next state 0. Present state 0, next state 1. Present state 1, next state 0. And when the present state is 1 and the next state is also 1. So this is number 1 case, this is number 2nd case, this is 3rd case, and this is 4th case. Okay. Then as it is, whatever we wrote the present state, that is Q here, we will copy this state as it is for the Q input of toggle. Okay, so here I will write as it is. So first case 0, this is second case 0, third case 1, and fourth case is again 1. Okay, and we know SR flip-flop inputs 0, 0, 0, 1. So this is as usual 0, and this is don't care. Then 0, 1 means it is a set condition, 1 and 0. 1, 0 means it's a reset case, that means 0 and 1, and 1, 1 is don't care condition. It is invalid input for SR flip-flop, 0 and X and 0. Okay. Now what we want is, we want to write the T input for the toggle flip-flop based on the present and the next state values of the flip-flop. Now see, case number 1, present state is 0. Next state also we want to get 0. Then what input you provide as a T input? The T input should be 0. Okay. Now second case, present state is 0, but next state we want is to get 1. So what input you should provide at T input? That is 1. Right. Third case, present state is 1, next state we wanted to get it 0. That means from 1 we want to change it to 0. So for that you again make toggle 1, because you just recall that whenever the toggle input is 1, the output of the toggle flip-flop will continue to change. And until you keep the toggle input 1, the output will keep on toggling between two steps alternatively, right? And when you want the fourth case, okay, when you want the fourth case, the present state is 1 and the next state is also 1. That means no change, no toggle. When you want no toggle, T input should be 0. Okay, so this is the table. Now again what we do is, we will apply the K-map technique. Okay, so what we do is we will apply the K-map technique in order to write the equation for S in terms of T and Q and R in terms of T and Q. So K-map for S in terms of T and Q, because we want to convert S into T and Q, right? So let us draw it. The K-map for two variable, right? So here on this side I will take T, here on this side I will take the Q. It is 0, it is 1, it is again 0 and 1. Now let us write K-map for S input here by referring to T and Q's. Okay. So first, when T and Q both are 0, for 0 0 T and Q both are 0. So what we are talking about, this particular condition. Okay. So T and Q 0 0, T and Q 0 0, the S will be 0, right? Here. When T is 1 and Q is 0, when T is 1 and Q 0, S is 1, right? When T is 1, Q is 1, S is 0. When both are 1, S is 0, right? And similarly, when T is 0, Q is 1, S is X. This is X. Okay? So what we do is, we can only group this single variable because this is the only case possible. Okay? We cannot combine with the don't care condition because it is located in the diagonal. So that we cannot combine. Okay? So what will be the expression of S in terms of Q and T then? S is equal to, we can write, so this is the min term. Okay, so this will give you TQ bar or TQ dash, right? Now similarly, let us write K-map for R input in terms of T and Q. Again draw the K-map, two variable K-map. Okay. So here again T, here again Q. This is 0, 1, this is 0 and this is 1. Okay. So now highlight this. We want to write the K-map for R in terms of T and Q. Okay. So when T and Q both are 0, R is don't care condition. When T is 1, Q is equal to 0, the R is 0, right? When T and Q both are 1, R is 1. So here, when T is 0 and Q is 1, R is again 0. Okay, so again here we can combine only this particular term. Okay, then what we get is R is equal to, in terms of T and Q, what we can write is T Q, T and Q. Okay, so finally we got the answers that we should keep S input of SR flip-flop is equal to T and Q dash. Similarly, R input of the SR flip-flop, if we give T and Q, then we will convert the SR flip-flop into T flip-flop. So let us redraw it, and please remember that we want to give input to S is equal to TQ dash, R input as TQ only. Okay, so let us draw how it look like, the SR flip-flop into T flip-flop. So let me draw it here. Again, let us say this is the S input, R input, Q output and Q dash output. This is SR flip-flop, right? And this is a clock signal, right? Now this is output Q and Q dash, right? Now what you will give S as an input? T and Q dash. T and Q dash. So Q dash is available here. Now you need to give input with the AND gate. So I will draw the AND gate. The output of AND gate is connected to S. And what will be the input for this AND gate? One input is T, right? One input is T. And another input to this AND gate we connect at Q dash. And where is the Q dash? See here. What I am connecting? The Q dash output of the same flip-flop in this way. And similarly, what is the R input? R input is the AND operation between T and Q. Again, we need one more AND gate, right, in this way. And we need to connect Q. So we are going to connect Q as one of the input in this way. Okay. And what are the two remaining inputs? The two remaining inputs are the toggle input. So here you write T input. Okay. So this is the conversion of SR flip-flop into corresponding T flip-flop. Okay. I hope you understood how to convert the SR flip-flop into D flip-flop, right? Then how to convert the same SR flip-flop into toggle flip-flop. Let us consider one more case of conversion. Okay, so where we want to convert the D flip-flop into toggle flip-flop. Okay, so let us see the third conversion. Let me write here conversion of D flip-flop into T flip-flop. Or in short, what we want to do is D flip-flop we want to convert into T flip-flop. How to do that? Again, let us start writing the table for conversion. Okay, so let us write. Again, start with the present state. Present state. How the present state is denoted? Present state is denoted with Q. Next state. Next state. Next state is denoted with Q plus. Right? Then what is the third column? Third column is the flip-flop to which we want to convert. So T flip-flop input. T flip-flop input. So what are the T flip-flop input? There is only one input T. Along with T, what we do is we will combine the present state, that is Q. Okay, and the flip-flop which we want to convert is to be written in the last column, that is the D flip-flop. D flip-flop input, right? So we know that D flip-flop again has a one input D, and we will combine D input with present state. Okay. So write the four possible combinations of present state and next state as usual. So let me write the present state is 0, the next state is also 0, the present state is 0, the next state is 1, the present state is 1, the next state is 0, and then fourth case when the present state is 1, the next state is also 1. This is case 1, this is case 2, this is case 3, and this is case 4. 0, 0, 0 to 1, 1 to 0, 1 to 1. Now what I will do is I will copy as it is the present state in the first column in the column of Q input of the T flip-flop as well as in the Q column of the D flip-flop. Okay, so I will copy this as it is for this, right, and for this, which I am highlighting with green color. Okay, so here you write this is 0, this is 0, this is 1, and this is 1. Similarly, this is 0, this is 0, this is 1, and this is 1. Okay. Now you need to write first D input. Okay. So by looking at the present state and next state. Present state is 0, first case. Next state is 0. That means the data input should be 0. Right. Present state is 0, but the next state is 1. Then the D input should be 1. right? Present state is now 1, third case, and the next state is 0. That means D input should be 0. Present state is 1, next state is also 1. That means the D input should be 1. Okay. So likewise, we should write now by looking at the present state and next state for combination, what will be the input of T. Okay. Please again remember that when the input of toggle flip-flop, that is T, is 1, then the output will toggle. When the input of T is 0, the flip-flop will not toggle. So this we need to remember. Now see the first situation here. First case, present state 0, next state 0. Is there any change in the next state from present state? No. Okay. So that's why the T should be kept 0, because there is no toggling. Now second case, see the second case, present state is 0, next state is 1. Is there a change in the next state? Yes. That means the toggle condition is true. That means T, you should make it 1. So likewise, third case, present state is 1, next state is 0. Is there any change in the condition? Yes. That means toggle is happen. That's why you keep T is equal to 1. And the fourth case, present state is also 1 and next state is also 1. So there is no change. So there is no toggle. Therefore, T input should be 0. Okay. Now, the same way, what we want is, we want to draw K-map for D in terms of T and Q. So let us draw it. K-map for D input in terms of T and Q. In terms of T and Q. So again, it is a 2 variable K-map, right? Okay. Okay. So here I will write T, here I will write Q. It is 0, it is 1, it is 0, it is 1. Okay. So first of all, let us write it for D input, right? This one, this column. First case, TQ, both are 0. When both are 0, D is 0. So this is 0, right? When T is 1, Q is 0. T is 1, Q is 0, D is 1. Right? When both T and Q, this we completed. When both T and Q both are 1, 1, D is 0. When both are 1, 1, D is 0, right? And when T is 0 and Q is 1, D is 1. In this way. So how we can combine? We can only combine this as a single terms, right? So therefore, what we can write? So this is equal to D. So how we can write for this particular term? This particular term is TQ dash. TQ dash plus, what about this particular term? This is T dash Q. T dash Q. Or we can write this as T XOR Q. Okay. Now let us write the K-map for Q. Okay. So we know that for D input there is only one input, and similarly for T flip-flop there is only one input, that is D. So there is no need to write a K-map separately for any other input, because both the inputs, that is D flip-flop as well as T flip-flop, they both have one input, and that expression of input in terms of T flip-flop we already formed out. Okay, so how the flip-flop will look like, the converted flip-flop, D flip-flop converted into T flip-flop, how it will look like. So here I will draw it. So this is, let us say, the D flip-flop. The output is Q and Q dash. Only one input is there, right? And this is, let us say, clock input, the clock signal, common signal. So what input you should give at the D? And we already found here this equation. Okay. So D is equal to T XOR with Q. Okay. So the two outputs, this is a Q output, this is a Q dash output. Okay. So we want to connect one XOR gate here at the input of D, right, in this way. And one input should be your T input, right, and the another input should be Q, which you can take from here. Okay, so this is conversion of D flip-flop into T flip-flop. Okay, so the T input is D flip-flop is converted into T flip-flop. So the conversion of flip-flop from one form to another form is very easy to understand. So in this particular session, we saw three typical conversion of the flip-flop given in one format and converted into another format. So flip-flop conversion, first of all, what we saw, the conversion of SR flip-flop into D flip-flop. Okay, writing the truth table, then writing the K-map design equations for given inputs in terms of expected outputs, and then drawing the flip-flop in terms of the given format. And the same we did for conversion of SR flip-flop into T flip-flop. And finally, we saw the third conversion of D flip-flop into T flip-flop. Okay, so this is all essential which is needed to first design the sequential circuit. Okay, so in the next lecture, what we do is by considering all this information whichever we studied earlier, the basic fundamentals of four different types of flip-flop, then how these flip-flops are working, and then today we saw how to convert the given flip-flop from one format to another flip-flop. By taking into all this information together, we will utilize this particular knowledge to construct our very first sequential circuit, and that is counter circuit. Okay, so I request you to just go through both of these videos. Okay, I repeated the first lecture because it was very essential to understand the fundamentals of flip-flop, how to draw the truth table, how to draw the excitation table, how to draw the state transition diagram, right? And then today in brief we saw how to convert the conversion, or how to do the conversion from given one format of the flip-flop into another required format. Okay, all this information and all this procedure we are going to utilize while constructing the sequential circuit. Okay, and in the next lecture we will start with building our first sequential circuit in terms of counters. Okay, so counters are sequential circuits which are essentially consisting of flip-flop as a basic building block. Okay, so in the next lecture we will see and we will start with counter. Next lecture is very important, and again I request you to go through these two video lectures carefully and understand the concept. Okay, so thank you very much for today.